Hello, everyone. We're going to go ahead and get started. So welcome and thank you for joining us today. My name is James Wong, and I'm the VP of Engineering for Peer Review Products at SmartBear. I will be the host today for this session. Our presenter is John Lockhart. John is our product manager and evangelist for the Peer Review Products. Now, in our nearly 10 years of working with our customers, and this is also validated through academic research and numerous case studies, code reviews have proven to be one of the most effective ways to improve quality. It also eliminates difficult to find customer reported problems, as well as reduce overall costs. In fact, code reviews done right can enable developers to spend more time on feature development work that they love to do rather than bug fixes. It also enables the business to deliver products on time. It's a win-win situation for both development teams and the business. So how do you realize these benefits and roll out a code review process that doesn't suck? So in today's webinar, John will take you through the practices that we have found to be most effective in implementing a code review process, and also concrete steps that you can take to get started. So with that, I'm going to now turn it over to John.
Thanks, James. Hi, this is John Lockhart. As James mentioned, I'm the product manager for peer review products here at SmartBear, and today's webinar is entitled How to Implement Code Reviews That Don't Suck. So we'll talk a little bit about benefits of code review, but keep that short. And I think we're going to focus this webinar on how to implement code reviews in your own organization. Now, before we get started, we'll just review the agenda. We're going to go through a little bit of housekeeping. This is going to be about how you can ask questions, how you can share this on Twitter, and how to get a replay. We'll talk about benefits of code review, how to get started, mix that in with a lot of best practices that are culled from a lot of research material and information we've compiled over the years that we've been helping organizations implement code review. And then we'll definitely reserve some time for questions and answers. Now, in terms of asking questions, given the number of folks that we have on today's webinar and the limited time, we're going to ask that you submit your questions in the questions panel. There's a little panel for you in the little GoToMeeting widget, and you can enter questions there. James is going to kind of line those questions up for me throughout the webinar, and then at the end we'll go through those. If you want to share information about this webinar, spark some conversations about code review amongst your peers and SmartBear, we'd be happy to have you share this using the Twitter hashtag code review, and we'll be conducting a follow-up session after the webinar. So other questions and other things that you want to discuss, we'll be following up via Twitter to kind of spark those conversations. And then you'll also have access to an on-demand replay of this webinar as well. So within a day, we will have kind of, edited it to kind of cut the front and the back off of it and get it in a format where you can go and view it online and share it with your peers and share it with other folks in your organization who might be interested in code review. So with that said, let's go ahead and get started in the presentation itself. And I just wanted to set the stage and kind of talk about what we'll learn today. Again, I want to try to keep this pretty focused. And again, we're going to talk about the benefits of code review, but that could be kind of a topic unto itself. I think what we wanted to talk about in this one is best practices and how to implement code review in your own organization. And one of the things I wanted to also have as a goal of this presentation is to talk about things that you can do today to, implement code review regardless of method. So whether you want to have sort of the old school meeting method and get folks in the room with a projector, or you want to do it via email, or if, hopefully you want to consider tool-assisted review using a product like the one that we publish, I think what you'll learn today will be relevant regardless of how you want to get started. Of course, being who we are and what we do, we're going to try to convince you, or I think there's a convincing case to be made that some of the best practices that we've uncovered over the years, they're not as obvious as you would think, and they would actually suggest that tool-assisted review is really the way to go. Now, so what do we know? What makes us the authorities? Where are we getting this information from? Again, this webinar will be available to you, but there are a lot of really good resources we've put together over the years that you ought to check out as well. And I'd say that they're sort of fall into sort of generally two forms. A lot of the information that we've compiled over the years has ended up in what we like to call the Red Book. And the Red Book is a little 100-page book that we've had, oh gosh, for 4 or 5 years. And it's got one of the largest case studies on code review ever done, a lot of contemporary information on code review that's all cited and referenced. So a lot of good information there. And I'll kind of be letting you or cluing you in on when I'm getting stuff from the Red Book, and then references to other articles and white papers that we have. Also, if you go to our website, if you go to the URL you see on this slide, that is, of every place on our website, that's the best place to go for code review resources, because we have a PDF of the Red Book and all of our case studies and white papers all on one page. They're really well organized. Something else about the Red Book too is that we do have hard copies of it available. You may, if you want to get a hard copy, follow up with us after the webinar, and we can arrange to get you a physical copy of the book, which is kind of a great kind of desk reference to have. Easy read. So let's go ahead and talk about why we would want to do code review. Just kind of a quick, again, we're going to talk about implementation, but wanted to go over, why do you want to do code review when there are so many automated tools available? You're doing so much in terms of trying to improve software quality. And so just to review the high points, I think to sort of sum it up, teams and industry experts really do agree, and there's a lot of evidence out there that, of course, code review is one of the best ways to find defects when they're least costly to fix, especially if you're doing pre-commit reviews before you even check the source code in. You're finding and fixing those bugs before they're even necessarily considered bugs. You're actually finding them and fixing them almost on the spot. And I didn't put a citation here because there are lots of things out in the literature that I'm sure you've seen are these charts that show you how the cost of fixing a defect goes up the farther down the chain it's discovered. So if you find it before it's checked in, least costly. If you detect it in testing, more costly. If it gets out into the field and it makes it into the hands of customers, it's most costly. The price of fixing it goes way, way up, along with all the subsidiary things that go along with having a bug in a released product. One of the things we also believe is that it's a great way to proactively manage technical debt. And I think this is something that folks kind of understand at a gut level, and you'll see a citation there to a paper that I've cited that's, I think, a good academic paper on the fact that, one of the things that you can actually do is have reviews of, different implementation options, interoperability issues, things that could improve the long-term health and stability of your code that you're never going to really detect through something like unit testing or static analysis. So code that works, but implementation that could be better, and better in the long term in terms of how readable, maintainable your code base is. Mentoring new developers and expanding knowledge of the code base. So this is one of the things that, again, allows you to bring on new developers and have a way of ensuring that their code is quality. helping avoid the what if somebody gets hit by a truck scenario, of being able to expand knowledge of the code base beyond the brilliant guy in the room who has the keys to the kingdom. It makes it a way to, again, socialize and expand knowledge of the code base. And then also finding defects that static analysis will never detect. And sort of two things on this slide. You'll notice there's the kind of the cartoon over to the right. Again, something that would pass static analysis, completely valid, but obviously not an implementation that you would choose. And that's kind of a comic example, but I think a perfectly valid example of the things that you're not going to get out of static analysis. Static analysis has its place. They're complementary. We think they're complementary technologies. And one of the more recent white papers that's on our site, it was in Dr. Dobbs in November, and you can download it from our site, is a Capers-Jones paper called Do You Inspect? And so this is a pretty, I'm not going to go into detail here because it's not the focus of this webinar, but that's a pretty in-depth discussion of why you should be doing both. You should be doing code review and static analysis. Now, something else I want to point out about why we ought to be doing code reviews is another little graphic, and the information from this graphic was pulled from the Capers-Jones paper. So these are his numbers, but you'd probably find similar numbers out in the industry. You look at where defects originate, and you're looking at, about 55% are in design requirements, documentation defects, 40% in code. Now, one of the things I want to talk around on this slide, and one of the curious things about code review, is that for the processes that generate these defects, documentation requirements and design, these typically all undergo review. So it's kind of a mystery, whereas you look at this missing review process. We review our documentation, we review requirements, we certainly do design reviews. Few people do code reviews, yet that's where 40% of your defects are coming from. So it's a mystery as to, okay, for this large chunk of defects that could be getting into your code, why are there no review processes? Now, some of that's going to be the fact that there are automated tools, again, unit test, static analysis tools. But again, I think there's a good argument to be made that, static analysis isn't going to get all of them. And there are a lot of other good reasons to be doing code review. This next slide, I'm not going to go into this in kind of detail, but just in terms of kind of comparing static analysis to pure code review, we've compiled information on how you can sort of look at them side by side and view them as complementary. So I'm not going to go into this in detail, but again, really points out that pure code review is good at detecting a lot of different kinds of evolvability issues or sort of technical debt issues, maintaining long-term stability, making your code more readable, more maintainable over time, and again, finding defects or design flaws that you just wouldn't get out of static analysis. So let's kind of take a turn and let's turn the question around. So I think what I wanted to do in the last few slides was kind of argue that answering the why question is pretty easy, and we could go into that in more depth. We could do an entire webinar on why do code review and make that case over and over again. What I want to focus on today is really the question of how to get started, and I think that's where most teams get stuck, is they can agree they can agree that code review is a good idea. They'd love to do it, but there seem to be too many obstacles, and I think those obstacles really come in terms of how do you start. Once teams get going, they find it an easy, simple, valuable practice. They get in a groove with it, but it's getting to that point that can be kind of hard, and that's what I want to address through the rest of today's session. So why don't organizations do code review? And we just want to review just a few of the reasons and the misconceptions. One of those is that code review has to be heavyweight. So most people who are familiar with code review, or the first thing they think of are sort of Fagan-style code reviews. Now, if you're familiar with Fagan, he wrote kind of a seminal paper back in the mid-'70s arguing for formal code reviews and outlining a very specific way that they were conducted. They had specific roles, specific ways materials were to be prepared, specific rules for follow-up. They were very formal, very thorough, very effective, but also extremely time-consuming. And that kind of review may be appropriate in some environments, but obviously over the years, development methodologies have changed. You move farther away from waterfall, more towards Agile, more towards an empirical approach, more towards shorter iterations in development, more iterative development processes. And so I think that one thing that can happen is that people just simply feel that they can't do code review because if this is what it is, if it's that heavyweight style review, it's just impractical. That this is the benchmark for what best practices are, and that's just not a practical solution for today's development methodologies. Some of it's going to be cultural resistance. People, when faced with the proposition of doing code review, often think that it's going to be around performance. So this is going to be something that's going to show up in your next performance review. Some people are sensitive to criticism. Some people are sensitive to commenting on other people's code. They don't want to feel like they're criticizing someone. There's kind of a social, maybe kind of a bit of a knee-jerk reaction, and we'll kind of talk about some ways in which I think that's also a misconception, that code review can be actually fun. It can be like a part of the job that people look forward to, as opposed to looking at it as not only a heavyweight layer, but something that's going to be used against them and not for them. Lack of best practices, we're going to talk about some of those. So obviously, especially if you're coming in not on a new project, but with like an existing code base, one question would be like, where do you start? So what do you review first? I mean, you can't obviously review everything. You've got to actually keep moving forward and keep writing code. But where do you start? And what are those best practices for starting reviews that are going to pay off and show you results early? And then also difficult to measure success. And I think this is something that's kind of a side effect of, again, meeting-based reviews. It's not a self-documenting process. And so how do you get yourself in a position where at the end of the day you can look back on how you've been doing code reviews and be able to demonstrate that they're paying off for you? So these are some of the things that I think when you add them up, these are reasons that people just avoid code review. Again, they can agree that it's a good idea, but it's hard for people to weigh the costs versus the benefits when they've got these kinds of considerations in the backs of their minds. And so that's one of the things that we're going to go over today. We're going to talk about how tool-assisted review can help with this. And I think also in terms of like selling code review in your organization, there are going to be some things that will help you win folks over. Because unlike an automated tool, I mean, you can really be kind of sticking your neck out if you want to implement this. I mean, you'll be a hero in the end when it works. But again, you're getting, you're trying to convince people to kind of change, to some extent, to kind of change the way they work. But I think we'll be convincing you that it's not something drastic, and it's actually, easier than you think. So let's just go through through some of the things that you ought to consider when you're implementing code review. And okay, one of these is going to be obviously the social and cultural factors. So when you mention code review, there may be kind of an immediate negative reaction. Again, and I think the part of it is folks don't want to open their code up to criticism, and that can be for ego reasons, but it can also be again, that they think that it's going to be a way to measure individual performance. And I think one of the things that you can do when you're implementing code review to make it more successful is from the get-go is to emphasize that it's not a performance review tool. It's about team success. And so one of the great things about tool-assisted review, like the Code Collaborator products that we publish, is that they're self-documenting and they automatically generate metrics. But in the design of those, we're actually really careful to design our reports and our metrics not around gauging individual performance, but really more about just the overall success of the review process as a whole. So I think it's important to again, to emphasize that, you should really, make it clear to folks that it's not, it's not a performance measurement tool. On the other hand, we kind of talked about the ego aspect of it, and one thing that you can leverage is that I think folks working on a development team, they all do have egos, but you can kind of turn that around and work it to your advantage. So, even if you're reviewing a small percentage of your code, if folks realize that, I'm writing this function, I'm writing this code, even if it's a small amount of code, the knowledge that somebody else might be looking at it, again, it provides them kind of an internal motivation to make that as high quality as they can, to adhere to coding standards and rules, and it just makes people more conscientious. So I guess the terms I would use is make it a matter of, incentivizing people to be conscientious, not making them fearful, not feeling like it's going to be a part of their performance review. Not like this kind of Siskel and Ebert parody you have of code review. Not the thumbs down, but really the thumbs up. And I think one of the examples, the concrete examples I like of this is we have a user voice forum where people provide feedback. And one of the things that our users have spontaneously asked for is like a like button. So they get into this groove of doing code reviews. It becomes socialized among the team. And so, in addition to making comments or even submitting reports of defects, there are actually things in there where you say, like, well, hey, this is really great. This is something you might want to go look at. This is something you might want to emulate. So again, I think there's a way to kind of turn that social and cultural factor around. Another question is going to be what to review first. Big question. So again, whether you're doing it through meetings or you've just gotten a tool to help you do review, what are you going to review first? And I think to sum up this slide, I think, again, especially initially when you're implementing code review, the basic principle would be you're not going to review everything. So start with things that everybody can kind of agree on. So some things that are consensus builders. And so one of the really good suggestions would be just get your developers to identify a list of the most frightening files, the hairiest code, the stuff that they think is the most brittle in your code base. Get them to identify those. Obviously things like changes to your most stable branch or the core module. One other thing you can do too that kind of softens the impact, or it can kind of lessen that resistance to criticism, is actually start reviewing unit tests. So it kind of gets people in the practice of doing it, kind of softens it up where they don't feel like they're having like their code criticized, but they're actually sort of more commenting on the tests that are going to drive the code. That could be particularly useful for a new project if you're doing things like test-driven development. Is implement code review at the same time. So start writing your unit tests, start reviewing those tests from the get-go. Again, it's a way to, again, get into the practice and kind of, back your way into it, ease your way into it through some kind of consensus building decisions. And again, that's why I think I like the, having developers vote on what they want to review first. Now let's go into some best practices that are a little bit more empirical, or sort of based on case studies and evidence that we've compiled over the years. So we're going to talk about, we talked about sort of the social aspects, we've talked about where to start. There are also going to be questions of how do you conduct efficient reviews? So how much should you be reviewing at a single time? Not only in terms of duration, but lines of code. And what other things can you do around the code review to make that as efficient as possible? And that is not getting false positives, but also not missing defects that are there. So just, again, making that part of it efficient. And these next few slides, I'm going to go through some sort of charts and graphs. These statistics are mostly pulled from one of the key chapters of the Red Book is the largest case study ever done on code review. And this was with one of our customers, Cisco, who did a 10-month study that involved, it was in 2006, it involved 2,500 reviews. The code base was basically about 3.25 million lines of code, and it was over 10 months. So they compiled a lot of data, and the interesting thing is that they were using Code Collaborator, our product, so that data was compiled automatically. So they just basically did their work, and then at the end of the day, they kind of handed over the data, and voila, there was this kind of this gold mine of evidence from us to work from. So just two things that you'll see in the this is kind of a summary of the slides, the next few slides that you'll see, but just to kind of summarize it, as a general principle, you want to spend about 60 to 90 minutes per review, and you also want to limit that to about 200 to 400 lines of code. So it's really looking at how effective are reviewers, both in terms of duration and lines of code. And you'll see that in the subsequent slides. And to kind of make a point about how we think tool-assisted review helps foster best practices is kind of a theme that you'll see throughout this presentation, is that shorter, more focused reviews, so reviewing less code more often in more depth, that's generally a best practice. That's hard to do with meeting-based reviews. So you think about getting into a meeting room with a bunch of people and a projector. One of my contentions is that there's kind of a fixed cost associated with that. Compiling the materials, getting the room, organizing everyone, getting them in the room. You've got a lot of investment there, so you're actually probably in danger of going beyond these parameters, because you want to get as much done as possible because you've invested a lot in just getting the meeting organized. And so one of the arguments for tool-based review is based on these statistics, and we'll take a look at that. So one of these is going to be just, again, the duration. And so this was, again, a chart that was pulled from the data in a couple of different studies. This one's not specific to the Cisco study, but in the Red Book, there's a chapter called Brand New Information that's got a series of studies that showed that the rate of defect detection starts to flatten out after about an hour. And this was verified by 3 or 4 different studies that we cite in the book, and there are others out there as well. So there's some general consensus that, again, no more than about an hour. Now, in terms of the lines of code, so you basically want to go slow. So what you're seeing here is that the inspectors who are hitting less than 600 lines of code per hour, they were generally above average in their ability to detect defects. And so once you start getting inspectors, so each one of these data points, consider this to be an individual reviewer, and this the number of defects they're detecting, and this the number of lines of code. Their effectiveness as reviewers falls off as the number of lines of code goes above 400 to 500. So somewhere in that range, no more than that, is about where you want to cap it. Again, this is another statistic to look at, is the defect density per lines of code. So how many defects per line of code do you get when a review is based on one of these numbers? So, for example, when you're reviewing 200 to 400 lines of code, the defect density for those individual files or those individual review materials stays rather high. Something else that we like to point out as well is the need to annotate. So annotation is yet, another best practice. And so what you're looking at here is the average defect density for a review with and without preparation. And so by annotate, this can kind of go back to, this is something that you would read back in Fagan, which is there's a stage prior to the actual review itself in which reviewers can go in and annotate files and instruct reviewers on what they might want to look at and explain certain features of the code. Now, again, that can be a fairly time-consuming activity. In tools, like if you're doing it through email, you could put notes in email. If you're using a tool like Code Collaborator, you can put comments in the code before you actually start the review. We have an annotation phase as a part of the workflow where people can go in and add comments. So it allows people to work more efficiently and the defect density goes up. Another key thing about annotation is that is also going to help eliminate false positives. So that's another thing that needs to be factored in when you're thinking about reviewing, and we'll see another example of that when we get a few slides on and we talk about meeting-based reviews versus single reader reviews, is that annotation can also help eliminate a lot of false positives. So the defects that are being detected, and when I say defects, these can be issues of a variety of types, not just pure and simple bugs, but it's going to help eliminate a lot of false positives. Something else that's recommended generally throughout the literature, and we advocate as well, is adding checklists. So one of the things that's kind of not obvious about checklists is that one of the things is that errors of omission are really the most difficult to find. So it's difficult to look for things that are not there unless you have something in front of you to remind you of what you're looking for. And then you'll see here, and cited one study that we cite in the Red Book that gives a pretty good rundown on a study where they compared formal multi-reader inspections and a couple other methods, and then had single readers use checklists, and checklists were by far the best methodology. But again, one of the things it helps you do is hit a particular kind of item that you're looking for, which are things that have been left out. So these could be certain kinds of coding standards, certain kinds of comments, other features of the code that were, again, something, if you think about a lot of errors of omission, a lot of them might not be picked up by automated tools or static analysis tools. Having a checklist is going to really help with that. In terms of like how you would structure a checklist, things we've written in the past kind of vary from like 5 to 20 items. I'd probably say about 10, so I kind of hit the middle ground there. Don't put things that are obvious in the checklist. Again, what you're trying to do there is remind people of things that they need to look at, the stuff they're going to miss, the stuff that's been omitted from the code. One of the neat things about checklists, too, is to think about the checklist as a way to help you develop your metrics and to help you do process improvement. So one of the things is if you have checklists, you can match what you're finding in your code reviews against what's on your checklist. So that can do two things. I mean, one is it helps you categorize what you're finding in the reviews so that you can feed that back into your development process. So if you're finding, bugs or issues or defects of a particular type, feeding that back into your process is actually going to make you're going to get fewer of those bugs in the code in the first place. And so you should actually kind of see your checklist evolve over time. So as your processes improve, you'd be able to see some historical data of what you're finding against your checklist. And then hopefully what you would do is you would actually start adding things on the checklist that are less and less obvious. So your processes would improve, your code would improve, certain things would fall off the checklist, other things would make it on. Just to give you an idea of like the kinds of things, this is just a slide that would, basically gives you just kind of an overview of some things that you might want to, typical things you might want to find on a checklist. I won't go through these in any particular detail, just examples, because this is going to vary so much based on the specifics of your environment, the kind of code you're writing, kind of languages you're using, the kind of tools you're using. But really, again, the last bullet there is meant to hit home that point, is that you would expect this list to evolve over time. So revisit your checklist. Don't write it once and have it be set in stone. It's something that you ought to come back and revisit. And again, hopefully what you would be able to do is use the checklist as kind of a benchmark of what you're finding and use it as a part of how you do your metrics. One of the other things that was really interesting as well, and I always found this to be a kind of a counterintuitive result, but I think one that's encouraging in the sense that it kind of takes some of the burden off of how you would do reviews, is are reviews that are conducted as meetings, are those more effective than what we would call single reader reviews? And so a meeting would be what you see in the picture up there, getting everybody together in the room with a projector or on a laptop and going through all the code together. And I think intuitively, you would think that meeting-based reviews might be better. And this study by Vada, and there are at least 2 others in the Red Book that we talk about, and there may be one since then, have basically contradicted that. So their results show that, at least in the Vada instance, that meeting-based reviews only detected about 4% more defects, but also potentially more false positives. So if you look at it, the counterintuitive result is it's almost a wash. So by getting everybody in a room to do meeting-based reviews, you're really no better off than if you were doing single reader reviews. And there can be kind of a groupthink and a kind of a synergy that's probably less helpful than it is maybe just potentially a waste of time. So kind of the conclusion is that single reader reviews can achieve the same results, and it's just a lot less time consuming. So again, this goes back to thinking about why don't people do code review? And it's because they think they have to do this. They're going to have to get everybody together, get them away from their desks, get them out of the zone, not writing code, not being creative, not being productive, and sit in a meeting. And it's just not necessary. Now, kind of a corollary of this is that if you're going to, so single reader reviews are so much more efficient, but kind of a corollary of it, and what we like to emphasize, is if you want to do single reader reviews, really tool-based review is the way to go. So you're going to need a way to gather up those materials and distribute them to those readers and collect the results that's efficient. A lot more efficient than doing meetings. If you're in a meeting, everybody can kind of just, have somebody annotate and write things down, and one person looks at the code, somebody else documents the defects, etc. This result that single reader reviews are more efficient really pushes you in the direction of going and looking at doing tool-assisted review. And so what do I mean by tool-assisted review? Well, I mean, when you look at the different kinds of code review, again, there's meeting-based, there are things like pair programming, which is a little idiosyncratic. It's kind of associated a lot with Agile, but I think it's associated with Agile because it's not meeting-based. It's not a formal process. It's a more interpersonal, 2 people programming together. Tool-assisted review, could be something as simple as email, as ineffective as email can be. But again, what I'll be talking about in tool-assisted review is looking at some kind of, automated software system for gathering the review materials, distributing them, managing the workflow, collecting the results, and doing the metrics. And so when we look at, why you would want to consider tool-assisted review, what I like to think is that in light of the results that we've seen through this webinar, is that tool-assisted review promotes best practices. And so one of the things that people might think when they're looking at code review is like, well, I could use a software tool, but wouldn't that not be as good as Fagan-style reviews? Or would that not be as good as the meeting-based reviews? I mean, those are more formal, they're more organized. Shouldn't those be better? And I think what you've seen, or what I've tried to convince you of during this webinar, is that no, that's not necessarily true. The results are kind of counterintuitive. You really having reviews that are shorter, more focused, also having reviews that are, again, single reader reviews, those are all things that are going to give you better results, or potentially better results, than more formal heavyweight reviews. But again, having a software tool to help you is one of the things that's going to make that possible. So when you think about tool-assisted review, one of the things that it can do is really help you spend more time on fewer lines of code. So for example, instead of having to gather a lot of material together for review because you've got one shot or one window of opportunity, most code review tools should have some form of integration to your source code control system. So you could put up, check in some code, submit a change list, and have the review focused on just that submission. So it's by the design of the system itself, it's going to implement these best practices. Most systems, again, using a software tool, you're going to have as many reviewers as you like, reviewers and observers potentially. But again, they're going to be able to review that code on their own. So you're not going to have to organize a meeting. You're not going to have to take them away from their work. It's a lot more efficient. But we've also seen that you don't lose anything in terms of the results. In fact, the results might be even better if you have people reviewing the code individually, providing things like annotations, and then being self-documenting and having built-in metrics. So you think about that Cisco case study. That would not have been possible had they been doing it through meetings. I mean, it would be possible, but not practical. Maybe that's a better way of putting it. This is also another key to, again, kind of trying to sell the idea of code review. If you believe in it, selling code review in your organization is its self-documenting process. But again, to address that social concern, it's not going to be used in anybody's performance review. It's a way to show how you're developing a culture of quality and you're putting out better code. And so I think these things are key in trying to understand, when you think about how to implement it. We've looked at best practices that you could do regardless of method, whether you're using a tool or whether you're using meetings. But I think these points are that these best practices are really reinforced and made much, much easier by using a software tool. So it's very rare that you get to have something both ways in life, and you kind of do with code review tools, because it makes the process more efficient, easier to do, even fun, and you get better results. That's not often that you're in that kind of situation. Some of the other things that tools can do, support for distributed teams. So when I talk to our customers about why they've chosen to use software to help them do code reviews, doing automated code reviews through a tool, again, distributed teams, probably top of the list. I mean, this is, again, when you think about why people don't do code review, meetings are hard. Meetings with distributed teams are harder. So it ups the level of pain. And so with a tool, it's actually quite simple. People, again, you get an email notification, you click on a link, it takes you to the code you need to review, and then it's all documented there within the software itself. And that gets back into some of the other things that tools allow you to do too. Simple materials gathering. Again, one of the big fixed costs associated with organizing a meeting-style code review is getting all those materials together. And again, being able to, from your Eclipse or Visual Studio or from the source code control management system of your choice, whether it's CVS or SVN or Perforce or Git, checking in code and specifying you want a pre-commit or a post-commit review and having the code go up and be distributed to the right folks, that's something that takes that fixed cost away. It's just kind of a part of the process. Something else that's also I've noticed is a big benefit as well is that regardless of whether you do code review or not, a lot of organizations are bound by regulatory compliance restrictions around code review. They got to do it, and they have to document it. And one of the things that I've seen in organizations that can be really painful is that code review begins to become an extremely cumbersome file management process. So they're taking code out of a repository and putting it in directories and then bundling it up into packages that can be signed off by certain people in management. This is somewhere else. I mean, if you're subject to those kinds of regs, like GXP kind of regulations, FDA regulations, you're doing medical devices. This is something that you're going to be doing already, but again, using a tool can make it infinitely simpler. Having things like electronic signatures, having an audit of what was reviewed, being able to demonstrate that on demand. So we're getting up almost on 10 till the hour, and so I want to kind of wrap it up and talk about, just to kind of sum it all up, what do I want, what do I want you to get out of this presentation? So when you step back and think about, what was I trying to convince you of, and when you think about going back and reviewing some of the materials and maybe getting the book or going back through this presentation, really what I wanted to support was the idea that code review practices, contrary to what you might think, and this is again based on all the evidence we've seen during this presentation, these best practices are not heavyweight. In fact, some of the heavyweight processes are maybe even counterproductive. So this is really, I think what we see as the way to do code review is a little bit contrary to some of the traditional, the traditional ideas, the things that, again, people have, when they've been in school and they've read about Fagan reviews, some of it's a bit contrary to that. I mean, Fagan reviews have their place, and, not to deprecate the work, but again, I think that there's evidence out there that they don't have to be heavyweight, and that when you want to go to more lightweight kind of agile style reviews, tool-assisted review is really the key to it, because they're just things that the tools allow you to do, and making those reviews lightweight that are just really difficult to do without them. And so having said that, we have right on about 10 minutes left, and I've completed all the slides I wanted to go through, and so what I'd like to do now is go ahead and let James go through some of the questions you folks might have asked.
Great, John. Thank you for that presentation. We've got a lot of great questions already. So I'm going to start. First question is, a lot of development shops are either Agile or moving to Agile these days. Can you talk about how code reviews fit into the Agile development process?
Yeah. So there's a natural way in which code review fits into Agile. So Agile has, two aspects of Agile development are, again, having really an emphasis on working code. So, checking in code that works and having shippable code, and also having shorter development cycles. And so code review really supports that in two ways. Okay, so when you talk about the focus on shipping workable code, that really necessitates that you detect defects earlier and earlier. So again, one of the things about code review is you're likely to eliminate a lot of defects, well, before they're even considered defects, before they even make it into the main code base. For example, if you're doing pre-commit reviews. So it fits into Agile in the sense that you're increasing the probability of having good shipping code before it even makes it into testing. The other aspect of how code review fits into Agile is that when you take a look at tool-assisted review, tool-assisted review really allows code review to fit into an Agile tool set. So I think one reason that people don't do code review or don't consider it is they think it's contrary to Agile. Now there is pair programming, which is a little bit idiosyncratic. It's kind of associated with XP and Agile, but that's not something that everybody can do, particularly if you have a distributed team. So a lot of people aren't going to do something like pair programming, maybe doesn't fit their culture or the way they work. They see the other alternative as being heavyweight Fagan-style reviews, which are absolutely, totally not agile. And they don't see that there's a third way, and the third way is really tool-assisted review, allowing you to incorporate the review process into those shorter cycles.
Okay. Another question that's similar to the previous one is, when is the best time in the software development lifecycle to do a code review?
Well, again, I think it's totally valid to start reviewing early. Reviewing, we talked about reviewing even things like unit tests. So incorporating code review into things like, test-driven development. So it could be, early, but again, if you, I don't know if there's really a best time. I just think it's different ways that you would approach it. So I think if you were starting a new project, if you were, earlier on in a project, yeah, you might want to try to review everything that's checked in. You may want to start with unit tests. On the other hand, if you've got a legacy product, again, going through and you're going to have to give some more thought to what you're going to review. You've got a larger code base. You're going to have to stay focused on looking at where you can make results. So I don't know if there's a best time. I mean, I think it's, any time's a good time, but I think it's going to be more about how you approach it.
Okay, great. Another question regarding static analysis. Those tools find the obvious bugs. So can you give some more examples of the type of defects that code reviews could find?
Yeah, certainly. So, over the long term, code review is going to allow you, I mean, again, for any, what code review really allows you to do is identify issues and bugs and defects that don't necessarily affect the functionality of software code in the short term. So you think about any problem that you're trying to solve with software, there are going to be typically multiple implementation options. And so what code review can help you do is choose implementation options that are going to help you manage technical debt longer term. So you're making better decisions earlier on. They're going to make your code more maintainable. Again, there are going to be other things in terms of stylistic issues. Also, another thing to consider, too, that static analysis won't necessarily do for you at all is more and more when you have interaction between, let's take a good example of hardware and software teams working together. There are interoperability issues. So if you're running static analysis on your code and they're running static analysis on their code, that's not necessarily going to help you detect things that are going to fail or not work properly based on interoperability between different systems. So it's also a great, code review is also, I think, critical to having collaboration between teams. So you consider, we've talked to analysts in, let's say, the automotive space, where they talk about how folks that are writing code for things like automobiles are critically concerned about interoperability. And this is a big deal to them because things used to be far more isolated. And so now your radio talks to different parts of your engine or other things, and things are more interconnected. Similar for like security issues as well. So I think another good thing, I mean, this is a really good question, is to also think about, the things that static analysis can't do in terms of things like interoperability.
Right. Here's a great question. Can you comment on code reviews and productivity? One of our software team leads is convinced that code reviews, even tool-based reviews, harm productivity. You and I know this is not true, but how would you convince this person?
I think probably what you would want to do is take maybe a more holistic approach and look at, again, this goes back to the cost of a defect to fix once it's made it into QA, for example. So what is the time that it takes? So talk about productivity. What is the time it takes a developer to fix a bug when it's written or close to being when it's been written into the code versus making it into QA, having the QA person write up a bug. Okay, so that's a cost to the QA team, but think about the productivity cost to the developer, who then has to go back, read the defect, try to reproduce the bug, go back into code that they may not be as familiar with, reproduce the bug, go back into the code and find it and fix it, and then by that time, other things have been written past it. So when you fix something, you can always break it too. And so I think you're looking at the inefficiency of a developer in fixing a bug once it's made it downstream versus detecting it earlier on. There's a lot of cost. It's not just a cost to QA or a cost to your customers. It's a cost to the productivity of your developers. Because it's again, think about it. Think about having to go into the bug tracking system, have a bug assigned to you, reproduce it, talk to somebody, figure it out, fix it, and hope that your fix doesn't break something because people have been writing code around the broken code that you've already written. So I think that's probably, when you look at lightweight code review, I think there's a pretty good case to be made there that it's you know, even in the short term, it's a productivity gain.
All right. Here's a question on checklists. Is a checklist recommended for the author, the reviewer, or both? And does Co-Collaborator have a facility to create one?
So they're really recommended, I think, primarily for reviewers, and we don't have something we have considered, and we don't have a specific checklist item. What people have typically done in Code Collaborator is that we have the ability to go in and add. The way that people do checklists now is it's not called a checklist, but we have kind of a general notes or chat area. So when you work in our tool, you can make comments at the review level, at the file level, and at the individual line of code. And so typically what we recommend as a best practice is that people go in at the review level, like the author. Let's say the author wants to write the checklist. The author could enter the checklist in the general chat or note sections of the review, or even put that in at the file level. And so it's just really kind of a part of the general conversation thread. And so that's basically how we do it in Code Collaborator.
Right. Here's a question on, in most of the teams that I work with, there's an imbalance with knowledge between various members. For example, one may know database in depth than other engineers. If there's an imbalance of expertise in the team, how can code review be implemented effectively?
Yeah, so one thing that might be a good practice is if you've got different areas of expertise, you may want to involve different members of the team, not necessarily as reviewers, but you could have them included as observers. So there are two ways that observers can function in a review. So you might have several people who have competence in, let's say, the database code, and you're going to put them on as reviewers because they're going to be making specific decisions about that code. But if you want a way to kind of disseminate knowledge and give people some visibility into that code so they can learn over time, you ought to set them up as observers on those reviews. And having observers can also be useful. Again, you think about these kind of interoperability issues where you have other people who aren't necessarily experts in your code, but they want to kind of be able to take a look at it. Like, they don't own your code, they aren't in control of it, but you want them to have some visibility into it. That's a good place for observers. And so I think to the question, I think putting folks on as observers is a good way that you could automatically sort of publish out, okay, here are things that you might want to be looking at to get up to speed on different aspects of the code. Because one of the neat things about a tool-assisted review is they're going to go in and they can look at that review, and they're not going to be just looking at the code. They're going to be able to see the whole chat thread. What have people been saying about this code? That's really going to be one of the best ways to learn.
Okay. And as we have a lot of questions, even though we're coming up to the top of the hour, we're going to extend the Q&A session for a while longer. So if you're able to stay with us, that's terrific. So the next question is, I'm a bit unclear with the meetings versus single reader reviews. Which could be best methodology to implement for code review for most of the time, and why?
Right. So I think the point of that study was that I think from an intuitive point of view, most people would think that getting folks into a room and, let's say, putting the code up on a projector and having everybody read and comment on the code would be a more effective way of finding defects. So, more eyes on the code, the more defects you're going to find. I think that it's just kind of an empirical observation. I mean, they did these studies, and it was an observation that that's not only inefficient, but there's really no gain in terms of the number of defects that you're going to find. That when you put people in a room like that and you have them all reading the code at once, they don't necessarily detect more defects. And so again, this gets back to how do you make code review efficient enough that you're going to get a good return on investment. And I think the idea there is, counter to what you might think, having people read the code individually and make their comments on their own, like when they're at their workstation or at their desk, is just as effective, but also more efficient. And so again, kind of the single reader review is a better way to do it. I mean, that doesn't mean that you have a single reviewer. You can have 50 reviewers. They just don't have to be in the room at the same time. I guess that's what we're getting at.
Okay. Here's a question on doing either pre-commit or post-commit reviews. Is one better than the other?
Not necessarily. We here at SmartBear, we tend to do pre-commit reviews. And I guess one of those practices, one of the reasons we do that is that the downstream effect for us is that as soon as something's committed, it typically makes it into a build and it goes into what we call our dog food server. So we're using our software, we're using that code live in production almost as soon as it's checked in. And it's checked in, makes it into a build, and then there it is. And so we like the pre-commit reviews because it fits better with the practice of being able to use that code immediately, whereas if it was post-commit, we'd have to be able to have more of a strategy of how to back that code out if it didn't pass review. So generally, I mean, I would think that pre-commit reviews are, if you can do them, are better. I mean, again, you just have to consider, you commit the code, then you review it, you always face the possibility of having to back it out.
Right. And here's a question on what are the setup times costs for the code review tool? I
sure.
That's referring to Code Collaborator.
Yeah. So exactly. So we have a product called Code Collaborator that's focused specifically on code, and then another product called Peer Review Complete, which does some additional kind of document review. In terms of the setup time, it's pretty easy to set up. You could download it, install it, and get it running in less than 30 minutes. It comes with a trial and an embedded database. So the setup is really, really quick. As far as the costs, I really need to get someone to follow up with you on that in terms of what it costs. It's it's a per user license, relatively inexpensive, and we could get someone to get you some information on that.
Great. Here's a question, kind of a follow-up on the Agile. How would you recommend code reviews fit into a Scrum process? When would reviews occur, and how does a team ensure reviews are done?
Sure. So in terms of how does it fit into a Scrum process, I'm not sure exactly how it fits into when I think of Scrum, I think of sort of the typical Scrum, the Scrum stand-up meeting. Reviews sometimes get discussed at Scrum meetings, but I think most of the activity around review and sort of occurs within the tool itself. And so maybe that question is how do you very efficiently make sure that in a very quick iterative fashion that reviews get done? And that is something that we do think a lot about in terms of the design of our own product, is that one of the things that people are most concerned about knowing is when reviews have been stalled. So if I initiate a review through a tool, it's great because it all just happens, but then you need a way to very easily see, okay, is this review moving forward? Are people participating? What's the quality of the review? So maybe people are signing off on the review, but are they actually really making comments? Are they really submitting defects? And so, or are they really submitting issues or having commentary about the code? So we have things in the review screens that present summary views of what did people do? And it's not like a metricing thing. It's just basically saying, okay, who's participating? So you can look down a column and you can see, okay, these people are chatting about the code. These people are submitting issues. These people have accepted comments or reviewed comments. So we give you some easy summary screens for seeing that. And then we also have, like, when a review seems like it is stalled, we have reports for that. So we can look at the data and tell you, okay, here are, 5 reviews where there just doesn't seem to be a whole lot happening. And then there are tools to do, like, you can email folks through the tool, but there are also things like we have a feature called Poke, which is a very quick way. If you just look at a review and it looks like, okay, this review just seems to be going nowhere, you can click a button and it'll just poke those people with just a stock message saying, hey, why don't you go take a look at this? This is something we need to kind of get moving forward. So to really kind of answer the second point, that's something that, yeah, is a big concern of our users and something we've tried to incorporate into the product. Because when you have that face-to-face interaction, you need stuff like that.
Right. And I would just add that, as part of the Scrum, that's the process that we use here at SmartBear as well. And it's such a natural part of our process to do code reviews, so we don't have to define that. But what you can do is have your definition of done for a user story to include a task that stipulates that code review must be complete for this user story as well. And that way you have a way to track that if you have a Agile project management tool to enable you to verify that's been done as well.
Yeah, definitely. Good point.
Okay. Well, we've extended the session beyond the hour by about 7 minutes, so we're going to go ahead and wrap up at this point.
All right. Well, thanks, everyone. This is John Lockhart. Thanks, everyone, for attending.
And a final reminder to, go check the hashtag code review on Twitter. We'll continue the conversation there.
Thanks a lot, folks. Bye-bye.